Today I'll be explaining 16.3 electric field strength, lesson 3 from chapter 16. So you can see here there's a sphere with negative charges, and we have the small dot which is called the Q naught, or the test charge or unit charge. So remember that before we took that the negative charges, so this is always positive, the test charge, and this has negative charges, the sphere. So remember, opposite charges or unlike charges, they attract, while the similar charges or like charges, they repel. So here we have unlike charges, so they're gonna attract, so the arrow would be toward the sphere with negative charges, while here as you can see, there's a sphere with positive charges, and here is the test charge, which is a positive charged. So here they are like charges, so they would repel, so the arrow will be downward. Now here we have another example. So here we have the charge here is positive, and remember we said the test charge or the unit charge is also positive, so they will repel. So this would be called E1. Now here, which is the electric field strength. Now here we have a charge with negative charge, and then here we have the unit charge which is positive, so they are unlike charges, so they will attract, so it would be directed towards the sphere, the negative charged object, and it would be called E2, which is the electric field strength. Electric field. Now the definition of electric field is the space around a charged object. The formula is E equals to F over Q. Equals to, remember that the F is Kc times Q times Q1 and Q2 over R squared. So here we have the R squared, and here we have this is the F. Then here we have the Q naught, which is this. So remember, this is the F, and this belongs with the, which is this one. So we're gonna cancel out the Q naught and the Q naught. So we have KCQ over R squared is left. So this will be the formula of the electric field, or the. Now the electric field, remember, it's a vector quantity, and the unit is Newton per coulomb. Now here we also have test charges, that here Q naught is positive, it has one positive charge, and here we have it has 3. And as you can see here, it looks different from A and B. It's like it's redistributed the charges in the spheres. Now we have, so now here we have the practices of practice D in the book. So we have the first question is a charge Q1 equals to 5 microcoulomb is at the origin, and a second charge Q2 equals to -3 microcoulomb is on the x-axis 0.800 meters from the origin. Find the electric field at a point on the y-axis 0.500 meters from the origin. So first of all, let's take out the givens. Five microcoulomb, and Q2 is -3 microcoulomb, and the distance is, we have two distances, or let's say radius. So now let's know how to draw it. So we have to draw it. So before that, let's convert the Q1 and the Q2. So it would be 5 times 10 to the power of -6 coulomb, and here it would be -3 times 10 to the power of -6 coulomb. So let's draw. So the test charge is over here, and then here we have the positive charge, and here we have the negative charge. Okay. So here we said that the distance is 0.5, and then the distance here is 0.8 meters. So this is Q1 and this is Q2. Now let's find out about the test charge, the electric field strength for each. Now first of all, we said that this is positive and this is positive, so what will happen? They are like charges, so they will repel, so the arrow will be directed upward, and it will be called E1. And then here we have positive charge, and then here we have the negative charge, so they are unlike charges, so they will attract, so it would be directed towards the negative charge. So this would be called E2. So this is Q1, and we said that Q1 is what? Q1 would be 5 times 10 to the power of negative 6 coulomb, and here it would be negative 3, which is the Q2 times 10 to the power of negative 6 coulomb. So now let's find the other distance over here. So we're going to use the Pythagorean theorem, which is, so it's this is the Pythagorean theorem, if you don't know. And then here we would use, it would be 0.5 squared plus 0.8 squared, so C would be 0.9 meters. Now let's also find the theta. So theta would be, theta equals to tan inverse, the opposite over adjacent, which is 0.8 over the 0.5. So now the answer would be for the theta is 58 degrees. Now let's do the second step, which is finding the electric fields, which is the E1 and the E2. Just to show this clear, this is the arrow going down, and this is the arrow up. So the second step is to find the E1 and the E2. So E1 equals to Kc, which is the formula, Q over R squared. So Kc is 9 times 10 to the power of 9. And then we have times the Q1, which is 5 times 10 to the power of negative 6 over the R squared, which is 0.5 over here, because it's between Q1 and the test charge, so we use 0.5 squared. So E1 will be 1.8 times 10 to the power of 5 Newton per coulomb. Now the E2, Kc, Q2, this is Q1 and this is Q2 over R squared, so 9 times 10 to the power of 9 times the Q2, so ignore the negative absolute value, 3 times 10 to the power of negative 6 over the R squared, which is the 0.9, because it's between the test charge and the Q2. So 0.9 squared. So the answer will be 3.3 times 10 to the power of 4 Newton per coulomb. So now let's move on to the third step. So the third step is to find the x and y components for E1 and E2. So now let's take it, put it on the x and y axis to make it more easier and to understand it more better. And so the E1 would be here, and the E2 would be here. So this is the E1 and this is the E2. Great. E1 would be here and the E2 would be here. So now let's find the x and y components for both E1 and E2. So for the x for E1 would be 0, and for the y it would be here, 1.8 times 10 to the power of 5 Newton per coulomb. Now for the E2, because it has both the x and y components, as you can see here, so we're going to use sine and cosine. So here it would be E2 sine 58 degrees sine, and here it would be E2 cosine 58 degrees, and from the theta that we have found before here, 58 degrees. and here it would be negative. So the answer would be here negative 1.74 times 10 to the power 4 Newton per coulomb, and the answer would be here 2.8 times 10 to the power 4 Newton per coulomb. Now the fourth step, let's find the sum of Ex and the sum of Ey. Now the sum of Ex, it would be 2.8 times 10 to the power 4 Newton per coulomb, and the sum of Ey, we add this to this, so the answer would be 1.6 times 10 to the power 5 Newton per coulomb. And now let's find the E net. Step, let's find the E net, which equals to radical sum of Ex squared plus sum of Ey squared, so the answer would be 1.6 times 10 to the power 5 Newton per coulomb. And the sixth step is to find the theta, which is tan inverse sum of Ey over sum of Ex. So the answer would be 81.1 degrees. That's the theta. Now that's it for the first question. Now moving on to the second question. A proton and an electron in a hydrogen atom are separated on the average by about 5.3 times 10 to the power of negative 11 meters. What is the magnitude and direction of the electric field set up by the proton at the position of the electron? So let's take out the givens. So here we have the radius is 5.3 times 10 to the power of negative 11 meters. So here they're saying the electron and proton. So we will use the Q equals to 1.6 times 10 to the power of negative 19 that we have used in the lessons before. So the formula is E equals to Kc Q over R squared. And remember, Kc is 9 times 10 to the power of 9. So 9 times 10 to the power of 9 times the Q, which is 1.6 times 10 to the power of negative 19 over R squared, which is 5.3 times 10 to the power of negative 11. One would be here, and the E2 would be here. So now let's find the X and Y components for both E1 and E2. So for the X for E1 would be 0, and for the Y it would be here 1.8 times 10 to the power of 5 Newton per coulomb. Now for the E2, because it has both the X and Y components, as you can see here, so we're going to use sine and cosine. So here it would be E2 sine 58 degrees sine, and here it would be E2 cosine 58 degrees, and from the theta that we have found before here, 58 degrees, and here it would be negative. So the answer would be here negative 1.74 times 10 to the power 4 Newton per coulomb, and the answer would be here 2.8 times 10 to the power 4 Newton per coulomb. Now the fourth step, let's find the sum of Ex and the sum of Ey. Now the sum of Ex, it would be 2.8 times 10 to the power 4 Newton per coulomb, and the sum of Ey, we add this to this, so the answer would be 1.6 times 10 to the power 5 Newton per coulomb. And now let's find the E net. Step, let's find the E net, which equals to radical sum of Ex squared plus sum of Ey squared, so the answer would be 1.6 times 10 to the power 5 Newton per coulomb. And the sixth step is to find the theta, which is tan inverse sum of Ey over sum of Ex. So the answer would be 81.1 degrees. That's the theta. Now that's it for the first question. Now moving on to the second question. A proton and an electron in a hydrogen atom are separated on the average by about 5.3 times 10 to the power of negative 11 meters. What is the magnitude and direction of the electric field set up by the proton at the position of the electron? So let's take out the givens. So here we have the radius is 5.3 times 10 to the power of negative 11 meters. So here they're saying the electron and proton. So we will use the Q equals to 1.6 times 10 to the power of negative 19 that we have used in the lessons before. So the formula is E equals to Kc Q over R squared. And remember, Kc is 9 times 10 to the power of 9. So 9 times 10 to the power of 9 times the Q, which is 1.6 times 10 to the power of negative 19. Over R squared, which is 5.3 times 10 to the power of negative 11, 2 to the power of 2. So the E will be 5.12 times 10 to the power of positive 19 Newton per column, which is the unit. Now we move on to the third question. So they said that an electric field of 2 times 10 to the power of 4 Newton per column is directed along the positive x-axis. And A, what is the electric force on an electron in this field? And B, what is the electric force on a proton in this field? So the givens are E, so this is the E. And then we use the formula E equals to F over Q naught. So we need to find the F, so we'll cross multiply, so the formula would be F equals to E times the Q naught. And the Q would be, because they said electron and proton, so the Q would be 1.6 times 10 to the power of negative 19 that we have used before in the lessons before. And so we apply the formula, so it would be 2 times 10 to the power of 4 times the 1.6 times 10 to the power of negative 19. So the answer for F would be 3.2 times 10 to the power of negative 15 Newton, because it is a force. So this answer would be both for the A and B. This answer is both for A and B. Now we move on to how to draw the electric field lines. So as you can see here, if you want to try to solve those questions, you can go back to the picture in the first page here. As you can see here, the lines are moving outward in the positive charge, while in the negative charge they are directed towards the negative charge, inward. So the first one here, Q1 equals to the Q2, and it's positive. So remember, it would be like that. So here we would draw and then also the same thing for this, and they will both bend like that. They're the same, remember? So like that. Now but here in the second one, the Q1 is bigger than the Q2, so it would be like that, and then it would bend. We do the same thing for the Q1, but for the Q2 it will change. Those lines will not exist here, so we'll just bend those lines. Now moving on to the second time, the negative. So remember, the positive is they're moving outward, while for the negative they move inward. So they will move inward, and then it will bend like this. The same thing for here, the Q1 and Q2 here equal to each other, so it will also bend the same. So here it will bend, and then lines would be like that. But then here the Q1 is also bigger than the Q2, so these lines will not exist here, only those lines. So it would be bent like that, and here nothing will change. It will be like that, and then lines will bend like that. Now moving on to the unlike charges. So we said that the positive, the lines move outward. Now here we will bend it in this way, and then we said that for the negative, the lines move inward. This is for Q1 equals to Q2. Now here Q1 is bigger than the Q2, so those lines will not exist here except this line. So this will happen because they are unlike charges, so they will attract. And here, because it's bigger. Now here the Q2 is bigger, so those lines will exist here, and then they will be like that, but then those lines will not exist here because it's smaller than the Q2. So this is Q1 and this is Q2. So it's like the opposite. So thank you, and this is the end for this section. Hope you enjoyed and understand.